Let us discuss this example. So in this example, we have a matrix space X D1. We have a sequence Xn in a matrix space X D1. So what we have to prove? We have to prove that if sequence Xn converges to X, the distance between Xn and X converges to 0. This thing we have to prove. Obviously, if all terms are moving towards 0, then distance of those terms from X is going to 0. For example, if I am going to Mumbai, if I am moving towards Mumbai, then distance between me and Mumbai is going towards 0. So the same concept we have here. See, let us start with by assuming one part. So here I am assuming first, suppose sequence Xn converges to X, and our target is to prove that D1 of Xn X converges to 0. Obviously, in definition of convergent sequence, we use epsilon. So let us take one epsilon first. So I have taken epsilon greater than 0 be given. Okay, so I consider here, mod D1 of Xn X minus 0. I am considering this one. We have to prove that, our target is to prove that this is less than epsilon. So let us work out on this one. So mod D1 of Xn X minus 0, that means we will have, say, D means distance cannot be negative, so there is no need of mod. This is nothing but D1 of Xn X. I will call it as equation number 1. See, we have what we have here, Xn converges to X. So we can use here definition of convergent sequence. So therefore, for above epsilon greater than 0, there exists n belongs to set of natural number such that D1 of Xn X less than epsilon for all n greater than or equal to capital N. By definition we get. So let us combine 1 and 2. So from 1 and 2, let me remove this diagram, it is not required now. See, from 1 and 2, what will you get from 1 and 2 if I combine? So here mod D1 of Xn X minus 0. Okay, D1 of Xn X and D1 of Xn X less than epsilon. So this is less than epsilon for all n greater than or equal to capital N. Getting the point? So that means we use A is equal to B and B less than C. So that's why A less than C, this thing we got. Yeah, therefore we can say by definition of convergent sequence, therefore D1 of Xn X converges to 0 in RDU, usual distance. See, usual distance, since we have used mod, mod means usual distance in R. So half part we have proved. In remaining half part, what we have to assume? We have to assume that D1 of Xn X converges to 0 and we have to prove that Xn converges to X. Make a screenshot of it first. See, conversely, we assume that D1 Xn X converges to 0 and we have to prove that sequence Xn converges to X. So I have assumed that part. Okay. So obviously in the definition of convergent sequence, we use epsilon. So I have taken epsilon greater than 0 also. Let us use definition of convergent sequence. So therefore we can write, therefore there exists n belongs to set of natural number such that, see, this is a convergent sequence in R with usual distance. So therefore mod D1 of Xn X minus 0 less than epsilon for all n greater than or equal to capital N. See, if you subtract 0, we will have same number. So mod D1 of Xn X less than epsilon for all n greater than or equal to capital N, right? See, if you take mod, but D1 is a distance, cannot be negative, so there is no need of mod. So therefore we can write D1 of Xn X less than epsilon for all n greater than or equal to capital N. This is definition of convergent sequence. So therefore sequence Xn converges to X. So implies Xn converges to X in X D1. Okay. So yes, in this way we proved second part also. So here we have completed the proof. Make a screenshot of it, then we will stop. Thank you. Bye bye.